Hello everyone, I am Vijay. RAG implementation refers to the process of integrating a retrieval augmented generation model into a larger system. RAG model combines natural language processing and information retrieval to enhance the quality and accuracy of generated content. Now we are going to the RAG implementation program. TQDM.notebook, a module from the TQDM library that provides a progress bar design. Pandas is a powerful data manipulation and analysis library for Python. Typing module provides type hints for Python, which helps in improving code readable and catching type-related errors during development. Datasets is a library provided by Hugging Face for working with datasets in the context of machine learning. Matplotlib.pyplot is a plotting library used for creating static, interactive, and animated visualizations in Python. PD.set and the set option is sets the maximum column width to none. Here we can store the datasets in the formation of ds equal to datasets.load underscore dataset of text. Load underscore dataset function to load a dataset of type text. Here we can use the RTF file, which is assumed to be in rich text format, and split equal to train indicates that the dataset should be split into train. Yet here we are looking at the chunking process. This line imports the recursive character TestSplitter class from the LangChain.TestSplitter module. This class is used to split the test document into smaller chunks based on specified criteria. And the next line markdown underscore separators. This list defines various separators that will be used to split the test. Each element represents a regular expression or a plain text pattern. And the next line doc test underscore splitter. It initialization recursive characters test splitter with the following parameters that are chunk underscore size, chunk underscore overlap, and etc. And the next line, we are initializing empty list and it iterates in the raw knowledge base. Raw knowledge base is starts the list comprehension which will generate a list of LangChain documents object. These modules are used to split the text document into smaller chunks. Set the embedding model name, specify the pre-trained model and its tokenizer to use for generating embeddings. This function splits documents from a knowledge base into smaller chunks using a specified tokenizer and chunk size. This initializes an empty list of processor. It iterates over each document in knowledge base and splits each document into smaller chunks using test splitter. The resultant chunks are added to docs processor. This removes duplicate chunks, checking if the content for each chunk doc.page underscore content is already in Unique test. If the content is unique, it is added to unique test and docs processed unique. This function returns the list of unique processed document. This calls the split underscore document process function with a chunk size of 1024 and the raw knowledge base. And this function is visualizing document length. And these are the important modules to initialize the RAG implementation programs. Accelerate is a library developed by Hugging Face to help developers run their deep learning models more efficiently. The Quanto library is designed for quantum machine learning. It provides tools and frameworks to develop quantum algorithms and machine learning models. The Quanto library is useful for researchers and developers working in the field of quantum computing. The Torch library is an open source deep learning framework developed by Facebook's AI Research Lab. It is used for building and training neural networks. The Transformers library, also Hugging Face, provides pre-trained model and tools to work with Transformers-based architectures. Face is a library for efficient similarity search and clustering of dense vectors. It's used here to vector store. To set the embedding model name, specify the pre-trained model to use for generating embeddings. You can replace this with the name of any other model you prefer. This initialization of the Hugging Face embeddings objects with specified models that are model name that specifies which model to use. Multiprocess that allows the multiple process for embeddings. Model walks that sets the device to CPU. Encode walks that ensure the embeddings are normalized. And this creates a phase vector stored from the process documents. Embedding model is to generate embeddings for the document. Here, user query is set to the string, which is the query the user wants to search for in the knowledge base. And retrieval docs stores the results of the similarity search performed on the knowledge vector database. Here we can denote the k equal to 5. This means retrieving the top 5 most similarity documents and print the content of the top retrieval documents. Here we can see the output of the query. Conclusion and future directions of RAG. Improved content quality. RAG implementation enables the generation for more coherent, relevant, and informative content by leveraging external knowledge. Enhance user experience. The integration of RAG models can significantly improve the overall user experience by providing more accurate and personality responses. Expanded capabilities. RAG implementation opens up new possibilities for developing more advanced and intelligent systems such as virtual assistants and content generating platforms.